In 1715, an astronomer named Edmund Halley, yes, the comet guy, had a brilliant idea. He would calculate the age of the Earth using salt. His logic was simple. Rivers carry salt into the ocean, and the ocean never empties. So if you knew how much salt arrived each year, you could rewind the clock and find when the very first grain arrived. When someone finally ran his numbers, they got 90 million years. The real answer is 4.5 billion. He was off by a factor of 50. And weirdly, understanding why he was so wrong is the best way to understand why the ocean is salty at all. Let's start with the obvious question. Where does the salt even come from? Because rivers, the things filling the ocean, are fresh. You can drink from them. So how does fresh water flowing into the sea make it salty? The answer is that rivers are not as innocent as they look. Rain is slightly acidic. As it falls and flows over rock, it very slowly dissolves it, stripping out tiny amounts of minerals, including sodium and chloride. The two halves of table salt. Every river on Earth is carrying a faint, invisible load of dissolved rock. In the United States alone, rivers dump around 225 million tons of dissolved minerals into the sea every year. It is the slowest, most patient robbery in history. The land, sneaking into the ocean, one atom at a time. And there's a second, stranger source. Deep on the ocean floor, near volcanic ridges, seawater seeps into cracks in the crust, gets superheated to around 350 degrees, dissolves metals from the rock, and erupts back out through vents called black smokers. The entire ocean cycles through these underwater chimneys roughly every 10 to 20 million years. The sea is, very slowly, brewing itself. But here's the first real mystery. Rivers carry lots of different minerals. Calcium, magnesium, potassium, all sorts. So why is the ocean specifically salty? Why table salt, and not chalky calcium water? The answer is life. For hundreds of millions of years, sea creatures have been pulling certain minerals out of the water to build themselves. Calcium gets snatched up to make shells, bones, and coral. Other minerals get eaten by plankton and algae. But sodium and chloride? Almost nothing wants them. So while everything else gets removed, salt just stays. And builds up. The ocean is salty because life ate everything else off the plate, and left the salt behind. Today, sodium and chloride make up about 85% of everything dissolved in the sea. Now, if you want to see this on fast forward, look at the Dead Sea. It's a lake with rivers flowing in, but no exit to the ocean. Water can only leave one way, by evaporating. And when water evaporates, it leaves every bit of its salt behind. So the salt builds and builds. The result is water nearly 10 times saltier than the ocean. So dense you cannot sink in it. So harsh that nothing lives there, which is exactly why they call it dead. It's the ocean's recipe, with the lid left off. So back to poor Edmund Halley. Why was he so catastrophically wrong? Because he assumed the ocean was like a bathtub slowly filling up. Salt going in, and nothing coming out. But the ocean isn't a bathtub. It's a machine, with a drain. Salt does leave. It gets buried in shallow seas that dry into giant salt flats. It gets locked into new rock. It gets blown back onto land as sea spray. Inputs, and outputs. And over millions of years, they balanced out. The ocean's saltiness has been roughly stable for at least 500 million years. Halley was trying to read a clock that had quietly stopped ticking. So is the ocean getting saltier? On a human timescale, basically no. It's in balance. But there's a twist. Climate change is heating up the water cycle, and the pattern scientists keep seeing is this. Fresh gets fresher, and salty gets saltier. The ocean isn't gaining salt overall. It's starting to concentrate it in the wrong places, which quietly messes with currents and weather. And finally, the number that puts it all in perspective. If you could pull every bit of salt from the ocean and spread it evenly over all the land on Earth, it would form a layer over 500 feet thick. Roughly a 40-story building. Of salt. Covering every continent. And it got there the same way Halley never understood. One raindrop, dissolving one speck of rock, for 4 billion years. If you just learned something gloriously useless, hit subscribe. We answer questions like these all the time.